Chapter 2, Exercise 2.81, Part A. Suppose the bond in a photochromic dye requires 321 kJ per mole to break. What maximum length is required to cause the eyeglasses to darken? The idea is to convert this to joule per bond, per single bond. That's the energy of the photon required to break the bond. Once we have the energy of the photon, we divide that by Planck constant to get its frequency. After we get the frequency, we can compute lambda. Lambda is the speed of light divided by the frequency. In the end, we need to convert our SI unit, meters, to nanometers and keep three sig figures. So first we have 321 kilojoule. Each kilojoule is 1000 joule. So we have this much energy per mole bonds. Now divided by the Avogadro constant. Alright, now we have the amount of energy required to break one bond. That corresponds to the energy of the photon. Okay, 5.3 times 10 to the power of negative 19 joule. That's the energy of the photon. Now divided by the Planck constant, we get the frequency of the photon. This is going to be a very large number. The frequency of the photon is fairly large. We can do some calculations here. You can see it's 8 times 10 to the power of 14 hertz. Alright, it's a very high frequency. Alright. Now, speed of light divided by the frequency, we'll get a very small number in meters. Alright, so this is 3.7 times 10 to the power of negative 7 meters. Finally, we convert it to nanometers. 1 meter is a billion nanometers. Let's see, 373. All right. Let's see how Mastering Chemistry tackles the problem. The energy of the photon is the amount of energy to break a single bond. It takes 321 kilojoule per mole to break the bonds. So they converted 1 kilojoule to 1000 joule. They converted 1 mole to 6 times 10 to the power of 23. So they got this number as the energy of required to break only one bond. That's also the energy of the photon. And then they use this equation to compute lambda. Alright? The energy of the photon is hc over lambda. So lambda is hc over the energy of photon. Well, I did it slightly differently. The way I did it is this. First, I get the energy per bond, and this is the energy of the photon. The energy of the photon divided by the Planck constant, I got the frequency of the photon. And then the speed of light divided by the frequency of the photon, I get the wavelengths in meters. Finally, I converted meters to nanometers. But same answer in the end. I might have used too many parentheses.